In this video, I am going to solve SSLC Model Question Paper 2 24-25 for Mathematics, which is issued by Karnataka School Examination and Assessment Board. It is a very important question paper since the many questions may repeat in the main exam. In this video, I am going to solve 3 marks question. There are 9 questions of 3 marks each, totally 27 marks. Now let us solve the 25th question. Prove that root 3 is an irrational number. Let us assume to the contrary. We know that it is an irrational number, but to the contrary that root 3 is a rational number. What is a rational number? We know that the rational numbers are those numbers which can be expressed in the form a by b, where a and b are integers and b is not equal to 0. Hence, root 3 is equal to a by b, where a and b are integers with no factors in common, means they are co-prime numbers. So, b root 3 transpose b here is equal to a. Now squaring on both sides and rearranging, what happens? B the square, b square. Root 3 the square is 3. A the square is a square. So 3b square is equal to a square. Therefore a square is divisible by 3. If we transpose 3 here, it is divisible by 3. And by the theorem, it follows that a is also divisible by 3. Now, so we can write a is equal to 3c for some integer c. Substituting for a, instead of a, let us put what? 3c. 3b square is equal to 3c the whole square. 3b square is equal to 3 square is 9, c the square is c square. Now we can cancel here. This is 3 square, 3c square. So b square is equal to 3c square. This means that b square is divisible by 3. And so b is also divisible by 3. This means that b square is divisible by 3 and so b is also divisible by 3. Okay. Therefore, a and b have at least 3 as a common factor. But this contradicts the fact that a and b are co-prime. This contradiction has arisen because of our incorrect assumption that root 3 is rational. So we conclude that root 3 is irrational. Hence proved. Now the 26th question. Find the zeros of the quadratic polynomial p of x that is equal to x square plus 7x plus 10 and verify the relationship between the zeros and the coefficients. Now we have the polynomial. What is it? P of x is equal to x square plus 7x plus 10. Now let us equate it to 0. So we get a quadratic equation. Now let us solve it by factorization method. By splitting the middle term. 5 plus 2 is 7, 5 into 2 is 10. So now let us write it as x square plus 5x plus 2x plus 10 is equal to 0. Now let us group it and take the common factors. So it is equal to x into x plus 5 plus 2 into x plus 5 is equal to 0. Here x plus 5 is common. Now group x and plus 2. So now we have x plus 5 into x plus 2 is equal to 0. here. So x plus 5 is equal to 0 or x plus 2 is equal to 0. So x is equal to minus 5 or x is equal to minus 2. Let us take x as alpha. One root as alpha, another root as beta. So alpha is equal to minus 5 and beta is equal to minus 2. Therefore, the zeros of the polynomial are minus 5 and minus 2. Now let us verify the relationship between the zeros and the coefficients. Sum of the zeros, alpha plus beta, minus 5 that is equal to coefficient of x, that is minus b, coefficient of x square, that is a, minus b by a. Now let us have alpha plus beta, minus 5 minus 2, that is equal to negative of 7. What is minus b? Now let us substitute. Minus b is minus 7, b is 7, so minus 7, a is 1. That is equal to negative of 7. Now product of the zeros, alpha into beta, that is equal to coefficient of c, constant term, that is c, by the coefficient of x square, that is a. Alpha is negative of 5, beta is negative of 2. If you multiply these two, you will get 10. C is 10, let us substitute by 1, that is equal to 10. Both sum and product of the zeros match the expected values based on the coefficients, verifying the relationship. Now the next question is calculate the mode for the following data. Class interval and frequency have been given. Now let us write them in vertical column. In the first column, class interval has to be written and the second column, frequency has to be written. And now we have to calculate mode by using the formula L plus f1 minus f0 upon 2 f1 minus f0 minus f2 into h. Now let us see which class interval has the highest frequency. Here 10 is the highest frequency, so this is f1. The class interval corresponding to the highest frequency is 12 to 16. So 12 to 16 is the modal class. L is 12. Lower class limit is 12. This is F0. The frequency of the previous class interval. 7 is F0. 1 is F2. Now let us substitute the values. So mode is equal to L is 12. F1 is 10 minus 7 upon 2 into 10 minus 7 minus 1. Here class size 16 minus 12, that is 4. Now let us calculate mode. How? 10 minus 7, this is 3. 2 into 10, this is 20. 7 minus 7 minus 1, that is minus 8. So now 12 plus 3 upon 20 minus 8 into 4. Now 20 minus 8 is 12. So mode is equal to 12 plus 3 by 12 into 4. Here it is very easy problem. 4 get cancelled. So here 1. Mode is equal to 12 plus 1. So mode is equal to 13. Therefore the mode of the given data is 13. Calculate median for the following grouped data. Now let us write a class interval in the first column and frequency in the next column. So now let us have cumulative frequency in the next, and how can we calculate cumulative frequency? In the first one, let us write 2, this one. 2 plus 4, 6. 6 plus 8, that is 14. 14 plus 5, that is 19. 19 plus 1, 20. Actually, median is equal to L plus n by 2 minus CF, that is cumulative frequency, upon F into H. Here, which one is L? How can we calculate? Here, n is 20, maximum total number of frequencies. N is 20, this number. N by 2 we have to calculate. N by 2 is 20 by 2, that is 10. 10 falls in which class interval? This belongs to 10, isn't it? It crosses 10. So 20 to 30 is the class interval. It is the median class. So L is 20. Frequency is 8. Frequency of the median class, that is 8. Now cumulative frequency, that is 6. Before that, let us calculate class size. 30 minus 20, that is 10. Cumulative frequency is 6. Now let us substitute the values. L is 20, n by 2 is 10, so cumulative frequency is 6, f is 8, class size is 10. Now 10 minus 6, that is 4. So now median is equal to 24 by 8, 20 plus 4 by 8 into 10. 4 ones are 4 twos are 2 ones are 2 fives. So median is equal to 20 plus 5, that is equal to 25. Now let us solve the 28th question. Prove that square root of 1 minus cos A upon 1 plus cos A plus square root of 1 plus cos A upon 1 minus cos A is equal to 2 cosecant A. Now the LHS is 1 minus cos A upon 1 plus cos A plus square root of 1 plus cos A upon 1 minus cos A. Now rationalize the denominator. For this one we have to multiply both numerator and denominator by 1 minus cos A. For this one we have to multiply both numerator and denominator by 1 plus cos A. Here in the numerator 1 minus cos A into 1 minus cos A, that is equal to 1 minus cos A the whole square. Observe the denominator 1 plus cos A into 1 minus cos A, that is equal to 1 minus cos square A. Here in the numerator 1 plus cos A the whole square. In the denominator 1 minus cos square A. Now let us cancel. Here we can convert 1 minus cos square A as sin square A. Here also we can convert 1 minus cos square A into sin square A because of Pythagorean identity. Now remove the square root. Here this and this get cancelled. Here also. So now it becomes 1 minus cos A upon sin A plus 1 plus cos A upon sin A. Here denominators are same, means LCM is sin A. In the numerator minus cos A plus cos A get cancels. So it is equal to 1 plus 1, 2 by sin A, which is equal to 2 cosecant A, that is equal to RHS hence proved. Now, or we can solve this question also. Here the LHS is 1 by secant A minus 1 plus 1 by secant A plus 1. Now we can take the LCM. What is the LCM? Secant A minus 1 into secant A plus 1. So now secant A plus 1 plus secant A minus 1 upon secant A plus 1 into secant A minus 1. Here observe in the denominator, what do you get? 1 plus secant A plus 1, secant A minus 1. By the identity A plus B into A minus B, which is equal to A square minus B square, we can rewrite this as secant square A minus 1. In the numerator, 1 plus 1 and minus 1 get cancels. Secant A plus secant A, that is equal to 2 secant A by secant square A minus 1. By Pythagorean identity, we know that secant square A minus 1 is equal to tan square A. Now let us rearrange this one. Let us convert secant and tan ratios into sin and cos ratios. 2 into secant A is 1 by cos A, this one. Tan square A is sin square A upon cos square A. So here this cos A and here 1 cos A get cancels. Now it becomes, this cos A goes to the numerator by sin square A. Now let us rearrange this as 2 sin A, 1 of the sin A, like this, into cos A by sin A. 2 by sin A is cosecant A, 2 cosecant A into cos A by sin A is cot A, which is equal to RHS, hence proved. Now let us solve the 29th question. The question is, the length of minute hand in a clock is 14 cm. Find the area swept by the minute hand in 10 minutes. Now this is the clock, this is minute hand, which is let us keep the central point as O, end of the minute hand as A, then it sweeps 10 minutes. After 10 minutes the position of the minute hand is B. According to the question, now we have to calculate the area of the sector OAC. The formula for the area of the sector is theta by 360 into pi r square. Here it is easy to calculate the radius. They have given radius is 14 cm, but they haven't given theta, angle, central angle. How can we calculate it? There are 60 minutes, you know it all, in full circle, which corresponds to 360 degrees. One full circle means 360 degrees, isn't it? Therefore, in 10 minutes, the minute hand sweeps an angle of theta, let it be theta, then we can calculate what is it. Now, theta is equal to 10 by 60 into 360. Here this and this cancels, 660s are. Okay, so theta is how much? 60 degree. Now we have theta 60 degree, we have radius 14 centimeters, so now we can calculate the central area of the sector OAC by using the formula theta by 360 into pi r square. Now let us substitute the values. Theta is 60, pi is 22 by 7. They haven't mentioned, no, you have to take such as values. Okay, 22 by 7 r square, radius square, 14 into 14. So now 7 ones are 7 twos are 0 and 0 get cancelled, 6 ones are 6, 6 are. Here 2 ones are 2, 3s are. Now we have what? 22 into 14 by 3, which is equal to 102.67. So the area swept by the minute hand in 10 minutes is 102.67 centimeter square. Or you can also solve this question. Find the area of the quadrant of a circle whose radius is 20 centimeter and also find the perimeter of the quadrant. I have put the circle here with the center O, radius, quadrant. Quadrant means 1/4 of the, here central angle is 90 degree. Quadrant. Its radius is what? 20 centimeter. Now we got the quadrant AOB. We are given what? Radius is equal to 20 centimeter. And we have to find area of the quadrant and also perimeter of the quadrant. Now let us find the area of the quadrant. The formula for which is 1 by 4 pi r square. Pi r square is the area of the circle. 1/4 the area of the circle, because here it is 90, no? So theta by 360, what happens? 1/4 into pi r square. Okay? And let us substitute. 1 by 4, pi is 22 by 7, r square 20 into 20. Here 4 ones are 4 5s are. Here we can understand that if we put 22 by 7, the calculation will be difficult. So if radius is can be cancelled by 7, then only we can put 22 by 7. Otherwise it is cumbersome. The problem will become cumbersome. So now let us put pi as 3.14 into 20 into 5. 20 into 5 is 100. 100 into 3.14, that is equal to 314 centimeter square. So area of the quadrant is equal to 314 centimeter square. Now let us find the perimeter of the quadrant. Here observe that perimeter of the quadrant, this plus this one, AB. So 2r, this is the radius, that is 20 centimeter. This length, how can you calculate? Full length is equal to how much? 2 pi r is the circumference of the circle. 1 by 4, 2 pi r. So 2r plus 1 by 4, 2 pi r. Now let us substitute the values of r is equal to 20 centimeter. Pi is 3.14. Let us substitute. Here 4 ones are 4 5s are. Now we have what? 2 into 20, that is 40. Here 5 into 2, 10. 10 into 3.14. What is that? 31.4. That is equal to 71.4. 40 plus 31.4 is equal to 71.4 centimeter. So perimeter of the quadrant is equal to 71.4 centimeter. In the figure, find the ratio in which the point P divides the line segment AB using the formula. Here, coordinates of the point A, it is on y-axis. So x coordinate is 0, y is 6 here. So coordinates of A is 0, 6. And coordinates of B, it is on x-axis. So here x is 3, y is 0. So coordinates of B are 3, 0. Now P divides in some ratio. We have to find the ratio. Now let us find the coordinate of P. What is it? 2, 2. Here also first x-axis, then y-axis. Okay, and the coordinates of P are 2, 2. Let the point P 2, 2 divides the line segment in the ratio m1 is to m2. Then by section formula, let us apply only x coordinate here. X is equal to m1 x2 plus m2 x1 upon m1 plus m2. Here we know x2, x1, so and also x is 2 here, x1, x2 is 3, x1 is 0. Let us substitute the values. Now let us simplify. So 2 is equal to 3 into m1, 3m1. This becomes 0. So 2 is equal to 3m1 upon m1 plus m2. Now let us transpose this to this side. What happens? 2m1 plus 2m2 is equal to 3m1. Now let us rearrange. Transpose to this side. What happens? 3m1 minus 2m1 is equal to 2m2. So m1 is equal to 2m2. m1 upon m2 is equal to 2 upon 1. So the ratio m1 is to m2 is equal to 2 is to 1. Or find the coordinates of the point which divides the line segment AB given in the figure internally in the ratio 1 is to 2 using section formula. Here from the graph we can understand that coordinate of A are 2, 5. X coordinate is 2, y coordinate is 5. And coordinates of B 5, 2. Now a point P divides. Let a point P somewhere, we don't know where it is, but internally. Let its coordinates be x, y divides the line segment in the ratio 1 is to 2. Now we have to find the coordinates of P. By section formula, x is equal to m1 x2 plus m2 x1 upon m1 plus m2. Y is equal to m1 y2 plus m2 y1 upon m1 plus m2. Let x1 is equal to 2, y1 is equal to 5, x2 is equal to 5 and y2 is equal to 2. m1 is 1, m2 is 2. By substituting the values in the section formula, x is equal to 1 into 5 plus 2 into 2 upon 1 plus 2. Y is equal to 1 into 2 plus 2 into 5 upon 1 plus 2. Now let us simplify x. 1 into 5 is 5, 2 into 2 is 4 upon 1 plus 2 is 3. So x is equal to 9 by 3. So x is equal to 3. Y is equal to 1 into 2 is 2, 2 into 5 is 10, 1 plus 2 is 3. So y is equal to 12 by 3, so y is equal to 4. Therefore, the coordinates of the point P are 3, 4. Now the 31st question. Prove that the tangents at any point of circle is perpendicular to the radius through the point of contact. What has been given here? A circle with center O with the tangent xy at the point of contact P. To prove OP is perpendicular to xy means angle OPY should be 90 degree. Construction. Let Q be any point on xy other than P. Join OQ. What is proof? The point Q must lie outside the circle. Therefore, OQ is longer than the radius OP of the circle. So, OQ is greater than OP. Since this happens for every point, if Q is here also, OQ is greater than OP. If Q is here also, here also, here also, every point on the line xy except for the point P. OP is the shortest of all distances on O to the points of xy. So OP is perpendicular to xy. A student bought some books for rupees 60. Had he bought 5 more books for the same amount, each book would have cost rupees 1 less. Then find the number of books bought by him. This is the 32nd question. Let the number of books bought by a student be x. Total cost 60 rupees. So the price of one book 60 by x rupees. If he had bought 5 more books, he would have x plus 5 books. The new price per book would then be 60 by x plus 5 rupees. According to the problem, this new price is rupees 1 less than the original price. So we set up the equation as 60 by x minus 60 by x plus 5 is equal to 1. Now let us take the LCM, which is x into x plus 5. In the numerator 60 is common. So 60 into x plus 5 minus x, that is equal to 1. Here x and x get cancelled. So 60 into 5, that is 300. Here multiply x into x plus 5, which is equal to x square plus 5x, that is 1. Now let us write transpose this to this side. So 300 is equal to x square plus 5x. X square plus 5x is equal to minus 300. Transpose 300 to this side is equal to 0. It is in the standard form. Now we can solve it by factorization method or by using formula method. Let us solve it by factorization method by splitting the middle term. Minus 15 plus 20. So x square is equal to minus 15x plus 20x minus 300 is equal to 0. Now group. Here x is common, here 20 is common. Now x into x minus 5 plus 20 into x minus 5 is equal to 0. That is equal to x minus 5 into x plus 20 is equal to 0. So x is equal to 15 or x is equal to minus 20. X is equal to minus 20 is not a valid solution since the number of books cannot be negative. Therefore, the student has bought 15 books. Now the 32nd question. In the figure, A, B, C are the points on OP, OQ and OC respectively. If AB is parallel to PQ, AC is parallel to PR, then show that BC is parallel QR. Here A, B, C are the points on OP. This is this one, this one. And AB is parallel to PQ. These are all given. This is parallel to this one. Now we have to prove that BC parallel to QR. Now in triangle POQ, where is POQ? Observe this one, POQ. You can clearly see that AB is parallel to PQ, isn't it? So it is given. So now we can say that OA by AP is equal to OB by BQ. Let this be equation number 1. Why? This is so because of BPT. Now in triangle OPR, where is OPR? This one, OPR. AC is parallel PR. Why? It is given. So it implies that OA by AP is equal to OC by CR. Let this be equation number 2. Why this is so? Because of BPT. Observe 1 and 2. OA by AP. LHS is same. Then RHS should be same. So OB by BQ is equal to OC by CR. Where is OB? This is OB by BQ is equal to OC by CR. This is in triangle. Which triangle? OQR. So BC is parallel to QR. Why? Because of converse of basic proportionality theorem. Hence proved.